Hello guys and welcome to FRQ2 of 2025. The solutions aren't out yet, so I may be wrong somewhere, and if you think I am, then please correct me. I'll honestly correct them. Okay, so FRQ2. A musician released a new song on a streaming service. I'm not gonna read the entire thing, but we have a musician, he has an app, and it also records the total number of plays since release in thousands. And we have an equation, the total number of plays in thousands for the song since release can be modeled by the function d, given by this one, d of t is equal to at squared plus bt plus c, where d of t is the total number of plays in thousands for the song since release. And we're asked to find in subpart 1, use the given data to write three equations that can be used to find values for constants a, b, and c in the expression for d of t. Okay, so we have three values. We have three constants a, b, and c. So you plug in each input value. So I'll start with t. This is the t value, and this is the d of t value. So I'll start by putting in t of 0. So we have a times 0 square plus b times 0 plus c, which should be equal to, the first output is 25. So we have 25. The second equation, we have a times 2 square plus b times 2 plus c, which should be equal to 30. And the third equation we have is a times 4 square plus b times 4 plus c, which should be equal to 34. I think that was quite simple, and yeah, you can evaluate them further. So, so for the first one, we have a times 0 squared plus b times 0 is 0, which gives us c is equal to 25. That was amazing. The second equation, 2 squared is 4, so we have 4a plus 2b plus c, which is equal to 30. And again, don't input c is equal to 25 and begin solving. That is for part 2. And in the third equation, we have 16a plus 4b plus c, which is equal to 34. And if I were a grader, I would give full credit for this part. Okay, so part 2, find the values for a, b, and c as decimal approximations. Now on test day, I recommend that you use Desmos or your graphing calculator, use regression or a graph or any way you're comfortable with, but solve it using a calculator. But in case you didn't and you solved it manually, I have an answer for you right here. It's not that hard and it isn't the worst idea to solve it manually. These are the answers. For those of you who use a calculator, you can cross-check your answers and move ahead. For the rest of you, here is a solution. So we have c is equal to 25 here, and we have two more equations in a and b. Now, the best step would be to substitute c is equal to 25 in the equation, and then you have a two equation in two variables. So if I use c equal to 25, I have 4a plus 2b to be equal to 5. If I subtract 25 from both ends, and then I have 16a plus 4b is equal to 9. Now I'll multiply this equation by 2 both ends, so I'll have 8a plus 4b is equal to 10. Now if I call this equation 1 and if I call this equation 2 and say I operate equation 2 minus equation 1, this will essentially cut off the 4b term. So I'll have 8a, my handwriting, 8a is equal to negative 1, which gives me a is equal to negative 1 over 8. There you go. Now pick an equation. I'll pick equation 2 again, and I'll substitute a is equal to negative 1 over 8. So we have 16 times negative 1 over 8 plus 4b, which is equal to 9, Now this evaluates to -2, and if I add negative to both ends, I have 4b is equal to 11, and if I divide both sides by 4, I have b is equal to 11 by 4, and that should be it. Convert them into decimals. -1/8 should be -0.125, 11/4 should be 2.75, and 25 is 25. Here are your three values. I hope the first part was quite clear. Okay, we're moving on to part B now. Use the given data to find the average rate of change of the total number of plays for a song in thousands per month from t equal to 0 to 4 months. And we have to express our answer as a decimal approximation and show the computations. Now, it means that we're supposed to find the average rate of change from 0 to 4. And we know that average rate of change is f of x2 minus f of x1 upon x2 minus x1, which is change in y over change in x. So the average rate of change, or the slope m for part 1, the slope m is equal to f of 4 minus f of 0 upon 4 minus 0, which will mean f of 4 is 34 and f of 0 is 25 upon 4, which is 9 over 4, which would give me 2.25. So the average rate of change from t equal to 0 to 4 is 2.25. That is all you need for subpart 1. Okay, subpart 2 is the average rate of change found in part B to estimate the total number of plays for the song for t is equal to 1.5 months, and we have to show our work that leads to the answer. Now, in this case, what they're asking for is for you to find the entire equation of the line. And we know that any equation and any linear equation is of the form y is equal to mx plus b, where b is the y-intercept, which means the output value when x is equal to 0, and m is the slope. Now we know m already, which is 2.25, right? This is our m, which we already found, and b is the y-intercept, and y-intercept is the output when x is equal to 0. So when x is equal to 0, which means when t is equal to 0, we have the output as 25. We have the output as 25. So my final equation would look something like y is equal to 2.25 times x plus b, which is a y-intercept, which is 25. Now I'm supposed to find out t is equal to 1.5. So I have y is equal to 2.25 times 1.5 times 1.5 plus 25. And if I quickly put that in the calculator, I should get 28.375. And there we go. This is the approximate y value for t is equal to 1.5 months. Okay, moving on to part 3. Let A sub t represent the estimate of the total number of plays for the song. And we have to explain in general why A sub t is less than d of t for all t, where t is between 0 to 4. And our explanation should include a reference to the graph of d and its relationship to A sub t. Now, I feel that most of the people may get this wrong because it's a very intuitive answer. So if you look at our relation, if you look at our graph d of t, we know it's a quadratic, and quadratic equations either have a parabola up like this or they have a parabola down like this, depending on the coefficient of x squared. Now, if the coefficient of x squared is positive, we have a parabola opening up, and if the coefficient of x squared is negative, we have a parabola opening down. So if we look at a, which is the coefficient of x squared, it is -1/8, which means that we have a parabola opening down. So you could figure out that your graph looks something like this. Okay. Now this is d of t. what is essentially A of t? How do you geometrically define A sub t? What is A sub t? Now, A sub t is the average rate of change when you take any 2 points. For example, if I take these 2 points, the average rate of change here would be this linear line. But if I take these 2 points, the average rate of change would be this. These 2 points, average rate of change would be something like this. Now, if you notice carefully, since the graph is concave down, every line connecting any 2 points in the graph will be below the actual graph. That is a fact, okay? Connect any 2 points on the parabola, no matter how hard you try, they will lie below the graph. And since A sub t is the approximation we make, and d of t is the actual graph, and we have the secant line always below the actual graph, we have that the secant line, which means A sub t, is always less than d of t. I hope the answer is very clear. So if you write down, if you first mention that, hey, we have a negative coefficient, so we have d of t to be concave down, which means the secant line, which is the average rate of change, is below the actual graph. Hence, A sub t is less than d of t. I hope this part was very clear. Okay, part C. This is again a bit tricky because the answer is a bit intuitive. So FRQ2 overall was a bit tricky, and it's okay if you didn't get full credit. So sorry. Part C is a quadratic function. Model D has exactly one absolute minimum or one absolute maximum, and this can be used to determine a domain restriction for D. Based on the context of the problem, explain how that minimum or maximum can be used to determine a boundary for the domain of D. Okay, that's interesting. So what do we have D? D is the total number of plays for the song since its release. Now, for example, if I tell you you sell 5 apples one day, then you sell 3 apples, then you sell two, then you sell four, eight, nine, seven, five. And if I tell you, give me a count for the total number of apples you sold. Okay, for example, on the first day you sold 2 apples, and then you sold three, and then even if you sold like zero, 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 zero apples for the next 3 days, the total number of apples you sold will remain five, right? I mean, you can sell more, you can sell less, and you can't sell negative, right? So which means the total number of apples you sell will remain positive or will always increase or remain constant. I hope you get me, right? You can't negative sell apples. So total number of apples you sell will either increase or it will remain constant if you don't sell any apples. This is exactly what's happening right here, okay? We have the total number of plays, the total number of plays for this song, okay? Now, as suggested by the graph of d of t here, we have the part decreasing right here. And as I explained you earlier, even if the musician gets no views or no plays for a particular period of time, he won't have negative total number of plays, right? So when I graph the function that we have here into Desmos, I get the maximum at t equal to 11, which is 40.1.25. 40.1.25 is relevant. What's relevant is t is equal to 11. So which means that the domain of D will be 0, which is less than equal to t, which is less than equal to 11. The reason is that after 11, the function starts to decrease, which in practical application is not allowed right here. Okay, I think that's the end of FRQ2. I hope you enjoyed it, and I hope everything was quite clear. If you have any doubts, ask me in the comment section below. Thank you. Have a good day.